I'm not getting all the buttons I normally get, so I'm a little concerned. Hi, my name is Carly McAvoy, and we are recording today rounding, estimating, and the mathematical properties. And that's lesson 5 for the Adult Basic Education 064 class. So when you round and estimate, that's pretty much what you're doing in everyday life, rounding and estimating. If you go to the grocery store and something costs $4.99, in your head you're thinking, no, that's $5. Because it's so close to $5, that's rounding. If you go into the store and you want to buy something that's $4.99 and $3.99 and $2.99, you say, well, $4.99, that's about $5. $3.99, that's about $4. $2.99, that's about $3. $9, that's about $12. That's estimating that you're going to pay about $12. You rounded along the way and you figured out that an estimate of your cost would be about $12. So that's rounding and estimating. We're going to talk about that today. Rounding happens, like I said, in everyday life, a lot in your head, but you can also round in math for other reasons. So the rule for rounding, I'm going to write the rule and then we'll practice it. If the digit to the right of the number you want to round is 5 or greater, round up. If it is less than 5, don't change the number. That's important because you don't ever drop a number down. You either keep it the same or you go up. You don't ever bring it down. All following digits become 0. So I'm going to read through that again. Hopefully you've written it down in your notes, and then you can read back and make sure that we understand what we're talking about. If the digit to the right of the number you want to round is 5 or greater, round up. If it's less than 5, don't change the number. And all the digits following that become 0. So I'm going to call that group 1. So let's give an example. Let's say I was going to round this number 737. I'm going to say 738 to the tens place. I would look at the tens, okay? That's the number I want to round. To decide whether I'm going to go up or down, I look one to the right, and the number on the right is 8. If it's 5 or greater, I round up, and that's what's happening here. So because it was more than 5, I'm going to round that up 7, and that becomes 4, and then everything following that becomes 0. So 738 is about 740 rounded to the tens. On the other hand, if I have something like 1,295 and I want to round, let's say this time I want to round to the thousands place, that's right here, then again I look one to the right. If I look one to the right and it's less than 5, the number is less than 5, then I don't change it. So if it's less than 5, don't change. So looking one to the right, I see a 2. That's definitely less than 5. So my 1 is not going to change, but everything after that becomes 0. So 1,295 is closer to 1,000 than it would be to 2,000. 1,500 would be right in the middle, so we would round. Anything less than 500 is going to be closer to 1,000. That's the general rule, and now we're going to practice it and see what happens when nines come in there, or that could be a little tricky. So I'm going to clear this screen. And start with a number. The first 5 problems on your practice sheet, if you have it out in front of you, are rounding. So feel free to kind of work on those. Pause this, try those, come back. You have something like this: 4, 8, 6, 3, 2, 1, 7. Any number. That's 4,863,217. We could round that number to the tens, the hundreds, the thousands, the 10,000s, the 100,000s, or the millions. We could do that. But in this problem, I'm going to ask you to round this number to the 100,000s. Which number is in the 100,000s place? That's where the first lesson that we did in this class was about place value, and you need to know that to be able to round. So which number is it? It's the 8. That's the 100,000s place. That's the number we want to round to. Anything in front of that, for our purposes, isn't going to change this time, but the stuff after that's all going to become zeros. But first we have to decide what's going to happen to 8. Remember, the rule is if the number to the right is 5 or more, you round up. If it's less than 5, you stay the same. Looking to the right here, I can see that I have a number 6, which is more than 5. So my number is going to round up to 9. The number in front of that didn't change, but everything following that becomes 0. So 486,217 is pretty close to 4,863,217 is pretty close to 4,900,000. So that would round up, and we looked at one to the right to decide that. Let's look at another one. They don't all have to be that big for us to round them. Let's say I have 7,243, and I ask you to round that one to the tens place. If you're rounding to the tens, what number would that be? Well, the tens is the 4. That's the tens place. So that, now to decide if we go up or stay the same, we'll look one to the right. Because 3 is less than 5, then you're not going to round up, you're going to stay the same. The numbers over here to the left aren't going to change either. And 4 doesn't change because the number to its right was less than 5. So that would just be 0. Anything following that's always 0. And that one, in this case, 4 wouldn't change either. 7,243 is pretty close to 7,240. So this is just rounding. When you round and then do a problem based on what you rounded, that's estimating, doing a problem using your rounding. Let's do another one. I want to show you what happens when you round with nines, because that's a little tricky. Remember, if we were counting by nines, that we would have something like, after we get to 99, the next number has to spill over to 100, and that's what happens when a 9 goes up, it becomes a 10, right? So don't forget that when we're doing this. So let's say I have 1,986,967, and I ask you to round that to the hundreds. What number is in the hundreds place? Well, it's this 9 right there. That's the hundreds place. And so what I want to do then is think about, do I round this up or do I keep it the same? Remember, I never go down, keep it the same, or go up. What I do is I look one to the right, and this is more than 5. Since it's more than 5, I'm going to round up. But when it happens, when I round 9 up, I get 10. So this becomes 10, and you have to carry that 1 like you would in addition. So now, instead of how I like to think of it, instead of 69, what I have there is 70. It rounds up 2 numbers. It changes 2 numbers, not just that 1 number. And then remember, everything trailing that becomes zeros, and everything before that stays the same. This is when you have a 9, when it changes something to the left. That only happens when you have a 9 there, but it can make a big change. So for instance, again, you should be writing these examples down. Taking notes is part of what you can learn from this class, is how to take notes effectively and be able to answer questions later based on your notes. Let's say I have 3,999,987. And I want to round that to the thousands. Which number is in the thousands place? It's this 9 right there. So I look 1 to the right and I see a 9. So that's more than 5, so I'm going to go up. What's going to happen is this 9 is going to become 10, right? So I put a 0, carry a 1. But now this 9 plus 1 also becomes a 10. And now this 9 plus 1 also becomes a 10, and I get 4 million. All these always become zeros. After the right of our number always becomes zeros when we're working with whole numbers and rounding. But when we're talking about to the left, it doesn't always affect it. You have to have 9s in there for that to happen, but this is a good example of one where it definitely affected it all the way down the line. So 9 is a tricky one, and you get a chance to practice that in your practice sheet. Also in there, I do have you practice rounding to the nearest dollar. The nearest dollar. So that one's easier for most people because most of you have dealt with money at some point and you kind of have a sense of money. So even though there's decimals in this problem, we're not going into decimals right now. But I just want to put it out there because you see decimals because you see money, and money has decimals in it. So it's probably something you're pretty familiar with. Let's say I was told something was going to cost $6.79. And so I ask you, what is that rounded to the nearest dollar? Well, the dollar, I should put the dollar sign in there. The dollar here is the 6. So the same rules apply, even though you could probably do this without really thinking about the rule. But look 1 to the right. It's more than 5, which means we're going to round up. And so I get $7. To the nearest dollar, that's 7. You can put your decimal points in there, but if you don't, that's fine too. I'm not so concerned about the way you write your answer, but that you know that $6.79 is about $7. It's closer to 7 than it is to 6 because it's more than $6.50, right? Because if we looked at a continuum here, we would have this. If it was $6 on one end and $7 on the other end, the halfway point would be $6.50. Anything to the right of that would be closer to 7. Anything to the left of that is closer to 6. And $6.79 is definitely closer to 7. So that would mean that would round up to the nearest dollar. What if I ask you to round to the nearest dollar $14 and 42 cents? Well, again, I'm kind of looking at what am I closer to here? Am I closer to $14 or am I closer to $15? Which end am I closer to? $14.50 is exactly halfway. 14's on one end, 15's on the other. And if you look at that $14.42, that's going to be to the left of the $14.50, right? So that would be closer to $14. But if you do it the way we've been talking about, then you would say, well, I'm rounding that to the nearest dollar, and that's 4. It's not the 1 because that's the nearest $10. I'm not asking for that. I'm asking for the nearest dollar. Looking to the right, that 4 is less than 5. since it's less than 5, you're not going to round up, you're going to keep it the same, and so that becomes $14. Everything after that, you can put the decimal point in with the 2 zeros or not, and again, I don't care about that. I just want you to know that $14.42 is closer to $14 than it is to $15. And one other thing I'm going to ask you to round is maybe to the nearest, this one I could ask you to round to the nearest $10. If I ask you to round to the nearest $10, then what's the number that you're looking at there? It's right here, right? That's $10. So that's the one I'm interested in. Look one to the right. You have a 6. 6 is more than 5, so you round up. Remember, if it was exactly 5, you round up. If it's 5 or higher, you round up. If it's less than 5, you keep it the same. So rounding up here, we're going to get 8. We have a 1 in front. Everything after that becomes 0. So the nearest $10, that's $180. If I have $725.40 and I ask you to round that to the nearest $100, then what number are you looking at? Then you're looking at the 7. That'd be $100. And so looking to one to the right, you see a 2. And 2 is definitely less than 5, so we wouldn't change that. That would stay the same, and that would be about then $700. So you should be able to round money to the dollars, even to the cent later, but because we haven't talked about decimals yet, I'm not going to do that. But you should have a pretty good sense about money amount. Is it closer to the dollar before or the dollar after? And remember that it's never going down. Stay the same or go up. So the next thing on your homework, I want to show you that real quick. The first part of your practice sheet, the first 5 questions here are asking you to round to the 100,000s place, the tens place, the millions place, the dollar, the $100. Those are all things that we just practiced. And then next thing it says estimate the sum, product, or difference by rounding each number to the nearest 100. When I'm asking you to estimate, I'm just saying do the rounding first, and then after you round, do the problem. So for this one, if I'm rounding to the nearest 100, what's $179 to the nearest 100? Well, it's rounding up. You're going to get 200. And for the next one, rounding, you're looking one to the right, it's a 2, so you would not round up. And then the problem becomes pretty easy then, because you've rounded these to numbers that are easy to work with. What does a difference mean? A difference means subtraction. So this is a difference right here. 200 minus 100 is 100. I don't really want that to happen. So I'll get rid of that. I better close this so I don't do any more damage to this thing. But I just wanted to show you what that looks like. So the next one, I'm not going to do the exact problem of your page, but something similar. 825 and 473. We're rounding this to the hundreds. All of them are rounded to the hundreds. What does this look like? Well, when I round this number to the hundreds, I look one to the right, I see a 2. That's less than 5, so I don't go up, I stay the same, but everything else becomes zeros. And for the next one, I have a 4. When I look to the right, I see a 7, more than 5, so I go up, and that becomes 500. I actually go up. What does the X means product? When that's a product, so we're going to be multiplying. When I have a bunch of zeros like this, it's so easy just to do the problem by just bringing your zeros and plunking them down in the problem. 1, 2, 3, 4 zeros. There's 4 zeros there. Just bring those down. And now the only real math I have to do is the 5 times 8. And that's 40. And I'm done. 400,000. When you have all zeros like that, you can just stick those zeros on the end and then do the math, do the multiplication for the rest of it. That's a really nice feature to have. Okay, let's take a look at another one. Let's say I have 753 minus 239. Again, I'm rounding these to the hundreds. This is in the hundreds place, and this is in the hundreds place. Again, these are not the exact problems you're doing on the practice, but they're very similar so that you can follow along. The top one needs to be rounded up because looking one to the right, it's 5, and the rule if it's 5 or higher, we go up. So the 7 is going to go up to 8, and the 2 looking to the right, that's less than 5, so that's going to stay the same. Doesn't go down, but it stays the same, and then I can do the subtraction, 800 minus 200, and that's a pretty easy one to do. Also, 8 minus 2 is 6, and of course these zeros are still going to be there, so you would get 600. And the last one in that set looks like this, something like 6,981 plus 237. We're rounding both of these to the nearest hundreds. That's here and that's here. Okay, so look one to the right for the 9 and you get more than 5, so you're going to round up. But what happens when you're rounding up? With a 9, it actually becomes 10, and so that becomes a 0, and we carry that 1 over there. So 1 plus 6 is 7. Then we have 0. Everything else becomes zeros. And down below, we're rounding to the 2. Look one to the right, that's less than 5, so it stays the same, and we get 200. Adding those together, remember our addition problem is called a sum. So we find the sum of that one because we're adding those together. All right, so that is estimating. Round each part, and it's going to tell you usually where to round. If you're out in the world and doing your own problem, if you're figuring out at the grocery store how much you think you're going to pay, or if you're trying to figure out, buying materials for something and trying to guess how much it's going to pay, then that estimate you can round to whatever you want. You can round to the tens or the hundreds or the thousands, however specific you want to be. But in these problems, it's going to tell you exactly where to round. So the next portion, I'm not going to write on it, but I am going to bring it up to show you. We did this rounding piece, then we did this piece, estimating, and now we're into this 10, 11, and 12, which says estimate the sum, product, or difference by rounding each number to the nearest thousands place. So this is telling you to the thousands. The last direction said to the hundreds. And just because we told it, I wrote it, I randomly picked those numbers. I could have said round to the tens or the millions or whatever I wanted, but I randomly chose that. Again, somebody will choose that for you when you're in a homework assignment, and out in the world, you get to pick that for yourself. What I want you to be able to do in 10, 11, and 12 is know when you read the word difference, what kind of a problem are you talking about? When you read the word product or when you read the word sum. So that's really what I'm testing here, because we just practiced the other thing, but I'm really testing your vocabulary skills here. What about number 10? Find the difference. What is that? Addition, subtraction, or multiplication? Hopefully you said subtraction. A difference is subtraction, so this one we're going to subtract. What about number 11, product? Addition, subtraction, or multiplication? A product is multiplication, so you'd be multiplying those two numbers. And the sum, it's the one we haven't used yet, which is addition. We're adding whenever we say the sum. So I'm looking for you to be able to round these things, but I also want you to know the vocabulary of what you're rounding to. Okay. So if you are, I'm going to do, any of these I can do. They're just like the last set. It's just the vocabulary that makes a difference. But let's say I ask you to round, I'm asking you to round to the thousands. So I'm going to do the number 12, well, similar to 12. Find the sum of 59,951 and 33,482. Okay, the reason I'm doing this one is because there's the tricky 9 thing that we're doing. And I asked you in the directions to round to the thousands place. The thousands place is here and here. So we're going to round those two. Plus, I asked you to find the sum, and that means addition. So I'm going to change this number. When I have the 59 and I look to the right, looking to the right, I have a number greater than 5, so I'm going to round that up. 59 basically becomes 60. Everything else becomes 0. And why that becomes 60 is because 9 becomes 10, carry the 1, the 5 and the 1 is how I get the 6, and the 0 from the 10 is there. Everything else becomes zeros. A sum is addition. And the second one, I'm looking at the 3 in the thousands place. Looking 1 to the right, that number is less than 5, so I don't round up, so that's going to be 33,000. Now add those together, and I get 93,000, my estimate of that. So you estimate these problems, first you round, and then you either add, subtract, or multiply. If you get stuck and you can't remember which is which, look back in your notes from previous lessons, or go online, Google it, look it up. If you look it up 100 times, probably by the 105th time, you won't have to look it up. It's okay to do something when you're at home. Use every resource you have available to you. You have a smartphone? Check it out. Look online. That's the time when you're learning. When you're in the classroom and you're asked not to use your phone or not to use your notes, that's because you don't need them anymore, because you used them when you needed them at home and now you're done with them. So it's not cheating to help yourself at home. It's cheating when we're told not to on a test, but at home, that's the idea, is that we want you to learn to be resourceful and find these sources and find this information out as you go. So don't be afraid to use what you have, a calculator, the internet, your phone, your friend, your textbook that somebody left behind for you or whatever. But remember, the idea is that by using those things, you eventually get it committed to memory, and then you don't need them at some point. So you don't rely so heavy on them that you're not remembering them, but use them when you need them. Okay, the next thing we're going to do is talk about properties and numbers for numbers. Somebody in the history of math proved some things. All right, so you can't just say in math, well, obviously 3 plus 5 is the same as 5 plus 3, because it's not obvious to us now, but it's not obvious to somebody originally, and they had to prove it. And so people went to the trouble of proving these things, and they're called properties, and it means that we can always rely on this to be true. No matter what numbers we use, it's always true for all the real numbers. Remember, the numbers started off with the natural numbers, that's what they were counting with, and then they added 0, got the whole numbers, and then there's some other things in there we haven't talked about, but the whole big thing was the real numbers. So for any real number you can think of, it would be true for any of these properties. And so they're overall true. So I want to talk about, I forget how many I'm going to talk about, 3, 4, or 5, but we'll know when we get there at the end of them. The commutative property is probably the first one that people talk about usually. It's a pretty straightforward property. When you get further on into math, you'll see these properties, instead of numbers, they put letters in there because they're trying to say it's not true just for 2 and 3, it's true for any number. And so they don't want to limit themselves just to showing it for numbers. But for this class, we're just going to use numbers. The commutative property could work for addition or for multiplication. For addition, it looks like this. 7 plus 9 is equal to 9 plus 7. In other words, if you want to write this in words, you could write it as changing the order doesn't change the answer. All right, that's what the commutative property says. Changing the order doesn't change the answer. 7 plus 9 is the same as 9 plus 7. That one's pretty straightforward, and for multiplication I could say 3 times 5 is equal to 5 times 3. Remember, when we write multiplication, we could use parentheses, or I could use the dot. Excuse me for a second, I'm going to sneeze. Maybe I'm not, maybe I am. All right, I think it passed. Okay, let's talk about the next property. Associative. The associative property also applies to either addition or multiplication. It's not about the order, it's about the grouping. I'm going to write that and then we'll come back to that. Changing the grouping doesn't change the answer. I do M's for N's a lot. I've noticed that. Doesn't change the answer. Okay? So when we talked about grouping before, remember we talked about parentheses and brackets and braces. Those are all grouping, so it doesn't matter which one you use. For our purposes, I'm going to use parentheses. But so if I have something like 5 plus 1 plus 11, well, right now what I have is grouped together the 1 and the 11. But what I could do is group together differently. Notice that I'm still going to write 5 and 1 and 11. I did not change the order. Remember, changing the order has to do with the commutative property. 5, 1, 11 is still 5, 1, 11. Didn't change the order. But what I'm going to do is pick these grouping symbols up and move them over, and I'm going to group 5 and 1 together and leave the 11 out. So I changed the grouping, but I didn't change the order. 5, 1, 11, 5, 1, 11. But I did change the grouping symbols. And that's true for multiplication as well. If I have 6 and then 7 times 8, I can write 6, 7, and 8, still the same order, but I'm going to move these parentheses over and make that 6 times 7 is grouped together, and then 8 is out by itself. So notice I'm not changing the order on this property, I'm just changing the grouping symbols. And remember that when a number is outside of parentheses, it means multiply unless you put a plus or a minus in there. If you don't see any other operation, we assume that it's a multiplication. Okay, commutative and associative properties. Let's go ahead and write those up here. The other two other ones, I guess. So I'm going to do 4. Didn't have that down before, but now I've seen the light. I'm going to talk about the identity properties. I'm going to talk about identity. The identity properties also apply to addition and multiplication. Why doesn't subtraction apply to the commutative property? The commutative property says we can change the order without changing the answer. Can you do that with subtraction all the time? Sometimes you can, but 1 minus 5 is not the same as 5 minus 1. Once you see a problem like that doesn't work, then you can't use it. So that's why we can't. In words, the identity property says you can perform an operation on a number but doesn't change its value. You can perform an operation on a number without changing its value. That's an identity. So what could you add to something without changing its value? 0, right? So I could take 7 and add 0 and I would get 7 still. That's the identity for addition. It's 0. It's called the additive identity because we can add 0 to something without changing its value. So let me write that down. Additive identity is 0. The additive identity is 0 because when you add 0 to something, it doesn't change its value. What do you think the identity would be for multiplication then? What can you multiply by and not change its value? And it's not 0 because if you take 7 times 0, you get 0, not 7. So you don't want to change its value. Well, it happens to be 1. Because 8 times 1, still 8. I performed an operation. I did not without changing the value. So if you add 0 or if you multiply by 1, you didn't change its value. Those are identity. That's the identity property. And so we call that the multiplicative identity. It's 1. All right, multiplicative identity is 1. The additive identity is 0 because multiplying or adding by those particular numbers doesn't change the value for a number. Okay, last property that we're doing is the distributive. When we do order of operations in a couple lessons, we'll get to talk about the distributive property more. But I'm going to talk about it now because we're talking about properties and it fits now. The distributive property has to have multiplication involved every time. You can have multiplication coupled with addition or multiplication with subtraction. They have to go together. So let's look at one where we would use multiplication in addition. So let's say I have 3 times 9 plus 4. The distributive property, and this is a little harder to follow at first, but this will be a property that you are going to love. You're going to use it all the way through algebra forever, and you're going to be glad that you have this property. So it's one you want to take the time to get to know. What this says right now is that we're taking 3 and we're multiplying it. We don't have to show that dot, but I could. That means multiplying it times the sum inside. The sum is the addition problem, right? Well, that's true, but what the distributive property says is we can multiply each one of those things separately. So we could take 3 times 9 And then, because it's addition, we would add, and then we would take 3 times 4. So I have the 9 and the 4 that I'm going to multiply by separately. And those two things are equal. And you can prove that those are equal. Over here, we'll do it off to the side. So let's do 3 times 9 plus 4. If we were to use the order of operations, which we will talk about in detail later, but a lot of people do remember this part, you do what's inside the parentheses first. So 9 plus 4 is 13, so you would say 3 times 13. 13 times 3, wave the magic wand or have it in your head, is 39. Remember, have that multiplication sheet. It may not go up to 13. Then you just have to write it down and work it out. What about the other side of this? We said that should be equal to 3 times 9 plus 3 times 4. Well, 3 times 9 is 27. That should be on your multiplication sheet. And 3 times 4 is 12. And then, that was a plus sign in the middle, and I wrote it as a times. That's bad. And I just want to get that off the record because I shouldn't have made that mistake. 3 times 9 is 27. It's a plus sign in between. And then 3 times 4 is 12. For some reason I can't write that plus sign right now. Let's see if I can do a better job. 3 times 9 is 27 plus 3 times 4 is 12. Nicely done, finally. And now I have 27 plus 12. 27 plus 12 is 39. So we can show you that whether you do it the left side or the right side way, it's always going to be equal. So that's what the distributive property says. We can have that distributive property for other numbers as well. Let's say I have 7 times 2 plus, or we're doing a minus this time, minus 1. What this says is that you can say 7 times 2 minus 7 times 1. That's the idea behind that, is you just multiply the number on the outside times everything on the inside. And we're distributing across 2 numbers. You could have more numbers than that. Everything on, if you have a number on the outside of the parentheses, it gets multiplied times everything inside the parentheses. Let's prove this one real quick while we're at it. 2 minus 1 is 1. And 7 times 1 is 7. Over here, 7 times 2 is 14. Minus 7 times 1 is 7. And 14 minus 7 is 7. So both sides equal when you do that. That one's going to be a little trickier for you. Write it down in your notes and just keep practicing it, and it'll start to come clear for you. And we can use this later in algebra a lot, so it's a good one to get to know. Okay, these are the 4 properties that I would like you to know. And the commutative property has to do with order. The associative property has to do with grouping. And the identity property has to do with a number's value not changing. Those are the 3 things. And distributed is a little harder to say in words like that, but we can prove it at least, so it's kind of a nice visual. Okay, you don't have to know how to spell these things on your homework. I'll show you what it looks like. Again, you should have your practice sheet already printed. But what I have is a list of things here, and I'm saying which property is being demonstrated. And then you choose them: associative, commutative, distributive, or identity. Sometimes people get more specific and say commutative using addition, commutative using multiplication, and I'm just going to ask you to just put commutative if it's commutative, whether it's addition or multiplication. When you get into basic math, Math 90 here at SPSCC, then they'll be more specific, and you'll be a little more specific. I'm just introducing you to these properties now. Okay, so number 21 and 22 would be nice if you could answer those. Number 21 says, give the rule for when you round up when rounding a number. So when do you round up? And that's something you can go directly back to your notes and look it up, or Google it, or ask your neighbor, whatever. You're at home, you can do that. I want you to keep asking until it gets in your out of your short-term memory and into your long-term memory. So the answer is, when you can round up is when a number is 5 or greater. If it's 5, the number to the right is 5 or greater. So whatever you're rounding, look one to the right, and if it's 5 or greater to the right, then you round up. If it's less than 5, 1, 2, 0, 1, 2, 3, or 4, then you stay the same. And number 22, when you are estimating an answer, you blank first, then perform the blank. What words would go in there that would make sense? When you're estimating an answer, you blank first. What are you doing first when you're estimating? First you round. You round the numbers to wherever they're told to do. After you round, then you perform the, and this is a vocabulary word we've been using so far throughout the class, and that is, then you perform the operation. So first you round, and then you do the operation. That's what estimating is. So it's really just rounding, but it's rounding with a purpose, so you can get to an estimate of a problem. Okay, we're finished today with rounding, estimating, and the properties. And that's the end of lesson 5, and you'll be ready for lesson 6 next. After you do the in-class worksheet with your teacher, and remember, if you find that you need more practice, you can ask them for worksheets to give yourself more practice, or you could always, if you're resourceful, go online and say, practice problems for rounding, and you'll find stuff on the internet. There's stuff for everything, right? You can find practice if you want to. All right, have a great day, and I'll see you next time.